Okay, another example of graph theory to get us used to the definitions. We have four friends, Ika, Bedad, Chris, and Diana. They have visited each other's houses as shown in the graph below. And so we have Ika, Bedad, Chris, and Diana. Whose house or houses has Ika visited? Well, this is what we call a directed graph. And so the arrows matter. And so if we look at where Ika is, the only house that Ika's gone to is Beta's house. That's the only house that she's gone to. Now, is this particular graph a connected graph? Well, or sorry, more specifically, a strongly connected graph. And the answer is no. The reason being is because if you start at A, there is no possible way to get to C. And so I could go to A to B, and then to D, and then to A. I could just go round and round, and I'll never get to C. In order to be a strongly connected graph, you actually have to be able to go from any path to any other vertex. So it's not strongly connected. Now it says to create the adjacency matrix. Well, if I have this scenario here, the adjacency matrix is quite straightforward. I just follow the arrows of A to A 0 times. A goes to B once. A never goes to C, and A never goes to D because the arrows matter. B ends up does not go to A, does not go to itself, but B does not go to C, it only goes to D. The only place out of D is to go to D. C does not go to A, it does go to B, does not go to itself, and it does go to D. And finally, D goes to A. D also goes to B. It does not go to C, and it does not go to itself. And so this is the adjacency matrix, and you just follow the directions as you go. So D part, who has gone to visit the most friends? Well, if I look at D, he goes to 2 friends, which I can see by looking this way on my adjacency matrix. This way also. So going out, D and C have both gone out to 2 different friends. If the question would have been who has been visited by the most amount of friends, well, that's going to be who's going in the most often. That's B. They have someone coming in here, here, and here. B must be pretty, everyone might want to hang out with B because he has the most friends that come to his house. And finally, we're asked for what is the in degree of Chris? Well, the in degree of Chris is 0. Nothing goes in. And if I do this, if I consider here going down the table is in degree. And if I want to do the out degree of Chris, the last part, the out degree, well, 2 is the out degree. And going this direction here, we go is the out degree. And so we can use our directed matrices to look at various aspects of our graphs as well.